This conference will now be recorded.
Hello, everybody. Thank you for joining us. This is Jordan Girth from the National Weather Service Office of Observations with another Thursday Satellite Book Club seminar series. This is session number 13. So thanks for joining us for those of you that are with us every week. Got a great presentation today. I'll get to the introductions in a minute. Just want to remind everybody that the session is being recorded and we will have opportunity for Q&A after the presentation. So if you have a question, it's best to put it in the chat room there and we will make sure we field your questions as they come in at the end of the session. We're pleased to have Dr. Stefan Beda, who is the Acting Office of the Chief Learning Officer, Executive Officer, and Science and Operations Officer at the Weather Forecast Office in Amarillo, Texas. He'll be facilitating those questions. If you are interested in presenting at a satellite book club, particularly if you're out there in the field and have a novel application for GOES or JPSS satellite data, please get in touch with us. Or if you're looking for training related to satellites that may be available or you don't know where to find it, feel free to get in touch with Brian Mata at OCLO for information or questions regarding that. I just want to thank the Tower S team, Lee Byerly and David Blutis, for arranging this, the OCLO, GOES-R, and JPSS for their support. Without further ado, I'd like to introduce Dr. Emily Berendt, who is a research scientist at the NASA Marshall Space Flight Center, and she works with sport. She specializes in research and applications related to hyperspectral infrared sounding retrievals and multispectral composites. Her research focus includes developing products derived from the sounders and multispectral composites through intercalibration and limb correction techniques. She's led multiple efforts to transition NASA and NOAA observations to operational end users in the context of multi-organizational collaborations with the GOES-R and JPSS proving grounds. Emily, looking forward to your presentation today on the operational transition of gridded NUCAPS to NOAA NWS and emerging applications. Thank you for being with us.
All right, thank you, Jordan, and thank you for the opportunity to present some of the work here. So with this particular project, you can see all the different logos and within the JPSS Proving Ground, we've had a lot of fun the last number of years, really watching NUCAPS products transform as we've gotten feedback from end users. So if you're not familiar with sport that's down at Marshall, it was established in 2002 to transition unique satellite observations and research capabilities to improve short-term forecasting and decision support. And you can see an example of the paradigm that we use that has been widely adopted by other communities and used heavily within the JPSS Proving Ground. Really working with the end users and listening to what they have to hear and making adjustments along the way. This concept has been used down at sport for 15+ years. So as far as hyperspectral sounders, if you're not familiar with them, they are on board SUMI MPP and NOAA 20. You have the cross-track infrared sounder and the advanced technology microwave sounder. And SUMI MPP and NOAA 20 have overpass times that are coincident with 1:30 a.m. and p.m. local time. So you get a really good overpass in the early afternoon. And some of that you'll see is stressed when we talk about the pre-convective environment, since you get a nice sounding observation between standard radiosonde launches. So NUCAPS is actually the algorithm, the NOAA Unique Combined Atmospheric Processing System that is used to create the CrIS ATMS soundings. So you get temperature, water vapor, and then you also get some trace gases and also cloud information. NUCAPS soundings are most accurate in the upper levels under clear conditions, but because there's a combination of the infrared and microwave measurements, this allows for measurements in partly cloudy regions. Usually you do not get an observation in really thick clouds or precipitating regions. I'll go through this quickly, but if you ever want to go back to, how is a NUCAPS sounding retrieved, this is somewhat of a high-level slide that gives you an idea of the process, where you get an initial profile that's derived from the microwave and full IR measurement channels, all sets of channels, and then cloud clearing is performed to remove the cloud signal. And then you get a physical retrieval using both the microwave and a subset of the cloud cleared infrared channels. So this is where a lot of error checking, diagnostic tests, and you get the sequential retrieval of temperature, moisture, and the trace gases and quality flags are applied. And then you get a final combined infrared and microwave NUCAPS sounding that is 100 layers. There are microwave-only NUCAPS soundings that do exist, but those are not in AWIPS. That bottom diagram is just a picture for you where you can see a NUCAPS sounding on the left and a radio sonde on the right. And you can see the difference in the detail that you get between a satellite sounding and a radio sonde. So the NUCAPS soundings are high quality observations, but you're really only able to get on the order of 4 to 6 layers of water vapor that's resolved and 6 to 10 layers of temperature that is resolved. So the importance of clouds, this is a really nice illustration. Nadia Smith put this together a number of years ago. So NUCAPS succeeds. You get a good observation when there's cloud variability. So NUCAPS retrieves a sounding if there's a radiated pathway past the clouds. So if you look at the diagram there, you can see you have a cluster of the 3x3 CrIS footprints, and the big yellow circle is the ATMS footprints. And so, you know, if you can get a signal past the clouds, then a sounding can be successfully created. The next slide is an example of how cloud clearing fails, or the NUCAPS sounding fails if there's uniform cloudiness, you know, or if there's situations where there's very thick clouds or there's precipitation occurring. NUCAPS is not able to basically see through or see around the clouds because there's too many clouds present. Okay, so NUCAPS soundings in NWS operations. So if you're not familiar with these types of displays, after this presentation, if you have access to your AWIPS, you can actually go to AWIPS and you can look for them. So since 2014, the NUCAPS soundings have been operationally available to all weather forecast offices and available as QT plots, as you see there, where you can click on a dot and then a sounding pops up in AWIPS. These have been demonstrated valuable for where conventional observations lack and between radio sonde launches. And there's a link to a paper about assessing the pre-convective environment and another link to the cold air aloft aviation hazard. So out of the work of just looking at NUCAPS soundings with forecasters in the context of the hazardous weather testbed and with cold air aloft, the idea came about as to, well, why don't we try and do plan view displays and cross-section displays? And that's where gridded NUCAPS came about. So the picture down below, you can think of, you know, taking that data that comes through the SBN to AWIPS and then transforming it to a plan view type of display or a cross-section type of display. So an experimental gridding process was developed around 2015, 2016, and it was taken to the hazardous weather testbed and to Alaska forecasters for cold air aloft. So, you know, after that point, we were able to partner with the Meteorological Development Lab and Jason Burks to actually develop the gridding capability right within AWIPS so that the gridding occurs on the fly. So this was released NWS-wide about 3rd of September 2019, almost a year ago. Myself and Nadia and Jason Burks worked together to kind of come up with an optimal type of gridding process where there was minimal interpolation, and then the fields that were available for display. So we came up with a menu based off of our experience with HWT as far as what would be of most interest. And you can see there the variety of temperature type of fields, moisture type of fields, lapse rates, there's a precipitable water, And then there's some ozone fields, the Haynes index, and the quality control. And so you can display things on single levels, some things you can display on layers. One thing that I just wanted to point out here is a quality flag. So, you know, if you take a look at NUCAPS and you're not sure what all the colors mean, there's a quick guide that Rebecca Esmali had put together, and it's available. I believe it was added to AWIPS in the air tool, possibly. So green basically means that you have a successful infrared and microwave retrieval under clear or partly cloudy conditions, so you can trust those NUCAPS soundings. Yellow means that you have a failed combined infrared and microwave NUCAPS retrieval, and you may actually have a successful microwave only NUCAPS retrieval under cloudy conditions. So when you look at the yellow soundings, there are times when the yellow soundings actually look decent and reasonable, and there are other times where the yellow soundings look very off the beaten path. And then red is where you definitely have both a failed combined infrared and microwave retrieval, and you have a failed microwave only retrieval. So you really definitely don't want to use those particular soundings. So just a kind of transition here to kind of a brief introduction into some of the applications that we have looked at and are continuing to look into. So cold air aloft is where the forecasters at the Alaska Center Weather Service Unit or Anchorage Center Weather Service Unit, they look for these pockets of temperatures that are less than 50 degrees Celsius, because it could be a hazard to aircraft flying through and cause freezing within the field. And so forecasters have adopted the gridded NUCAPS into their operations, where they're able to look at the vertical extent of the cold air aloft and also look at the horizontal extent of the cold air aloft. You know, previously they would just use the limited number of radiosonde sites and model data to try and anticipate the extent of the cold air aloft and feed that into their meteorological impact statements that they correct. So NUCAPS provides them a little bit more data to do that. As far as the pre-convective environment, with going to HWT, the goal was really to test the utility of gridded NUCAPS for analyzing the pre-convective environment. You know, so knowing that NUCAPS has thermodynamic information, how can that be used in clear to partly conditions leading up to convective type of situations? So what really came out of HWT is that gridded NUCAPS, you know, is really good at assessing thermodynamic spatial gradients and patterns. So if you can look at how relative humidity is changing over your area of interest, or temperatures, or even look at things such as lapse rates or TPW or LPW, it can provide a lot of information to the forecasters and give them another tool to compare to model data. So here's just another example. We used the opportunity at HWT to really fine-tune the product so that forecasters could view the data on standard pressure levels. Prior to that, NUCAPS automatically comes out on non-standard types of levels. So you don't want to look at 496 millibars, you want to look at 500 millibars. So we put a lot of effort into appropriately vertically interpolating the data to standard levels. And then we did a lot of investigating into what AWIPS-derived parameters are valuable to provide additional NUCAPS fields. You know, lapse rates, Haynes index can be calculated. There are stability indices that can be calculated, but we're still evaluating their effectiveness. We did create AWIPS procedures and recommended fields out of HWT, and that's where the idea for the menu came about. And best practices to address data quality and gaps. Before, we were basically masking out all the poor quality data, and we got feedback from the forecasters that they would rather visually mask out the poor quality data rather than having it removed for them. So some of the emerging applications, fire weather, the NUCAPS can be used to look for the low-level thermal ridge and assessment of the Haynes index, stratospheric intrusions and cyclogenesis by looking at ozone-derived types of fields, turbulence, you can also look at ozone type of fields and upper level lapse rates. And a new one is assessing the tropical cyclone diurnal cycle and changes in tropical cyclone environment. So Erica Duran at SPORT is starting to look at research and applications related to tropical cyclones. Diagnosing the breadth and extent of the Saharan air layer, that's a emerging application that Arunas from NRL is looking at and digging into pretty deep. And Scott, I see that you're on here. I still have up here assessing the rain and snow line transition by analyzing low-level lapse rates, dew points, and surface temperature. So, you know, really any assessment of the thermodynamic environment in clear to partly cloudy conditions, NUCAPS can provide you information, especially about gradients. And Scott has done a really great job of finding examples and blogging about applications. So I have a link to the SIMS blog there. So here's just one example of fire weather. So this is the Rhea, Oklahoma fire that started on 12th of April in 2018. And these are just examples combined with model data in NUCAPS to diagnose the low-level thermal ridge. So you can see here's Rhea, Oklahoma, and an area where you can see elevated surface temperatures being advected into the region. This one is 2-meter relative humidity with the model data overlaid, and you can see kind of the same thing, the very dry conditions in a ridge-like pattern. Going into the area, and this is more upper level, so 750 millibar temperature with 500 millibar wrap heights overlaid. And this panel over here is all model data. So you can see this area of 750 millibar warmer type of temperatures that is also captured within the NUCAPS. And so this really just shows the strength of NUCAPS to be able to pick out those broad synoptic type of features and the spatial gradients. And then here's the Hain index. So this is calculated on the fly within AWIPS. And so you can see this axis of higher Hain's index near Rhea, Oklahoma, and you can also see that in the model data. And so it can give forecasters added information on the potential for fire growth. So here's some examples for cyclogenesis. So there's these ozone dry fields where we have total column ozone anomaly, and also tropopause level, that they're all derived from the ozone from NUCAPS. The ozone anomaly gives you an idea of whether or not you have anomalous ozone that would be representative of a stratospheric intrusion or tropopause fold. And then of course, tropopause level gives you an idea of how low the tropopause is extending. So since ozone is a tracer for stratospheric air and tropopause folding, you can assess for trends in cyclogenesis. You can anticipate whether or not you'll have hazards such as high winds or high waves because you have you know, stronger cyclogenesis that's induced by some type of stratospheric intrusion or tropopause fold. And so this is just an example where you can see that air mass RGB cyclones being evaluated, and you can see an area where there's a potential for stratospheric intrusion, tropopause folding, and then an area where the tropopause indeed is a little bit lower. So this is a tropical cyclone environment. So tropical cyclone radial anomalies can show differences in thermodynamic fields in both the near storm and surrounding environment. So Erica at SPORT, Erica Duran, she created this technique that she creates these anomalies by bending the soundings. So she takes an overpass, and the soundings are sorted into 100-kilometer radial bends centered on the TC out to about 800 kilometers. And then she creates a daily mean sounding for each radial beam. And then the daily mean profile is subtracted from the sounding with each radial bend to yield a temperature or moisture anomaly. And then anomalies are converted to local time and composited every 4 hours. So you can see like a nearly equal and opposite anomalies at 12-hour intervals to basically demonstrate the diurnal cycle. that you have the afternoon and the morning profiles here. And then she has applied basically a technique to plot this in plan view so that you can pick out gradients in water vapor. You can pick out gradients in temperature, but this just happens to be a water vapor example. And then you can kind of get a sense of how the atmosphere is changing and how the environment is changing. Rebecca at STC has worked with Erica to set up a 2020 hurricane season NUCAPS radial anomalies that are being calculated real time. And all the storms for this season so far, you can go back and look at radial anomalies. So just a real quick summary here. NUCAPS soundings were operationally transitioned to NWS in 2014 through the hazardous weather test bed, the JPSS sounding initiative. We've all collaborated very closely to find opportunities to introduce hyperspectral sounders to forecasters and expand the types of applications that they can be used for and the techniques to display them. Products have been tailored to the best of our ability to meet the operational environment. And so as a result of consistent user feedback, the gridded NUCAPS has been transitioned to operations, but honestly, it's still undergoing active development. That there's feedback that we're getting, where there's bugs that we realized that were in the code, and we're working on and addressing some of those things. New applications include fire weather, cyclogenesis, turbulence, assessing the tropical cyclone environment, but can really encompass any assessment of thermodynamic fields in clear to partly cloudy conditions. And we're always, open to hear some of the ideas that people come across. So, thank you for the opportunity to present, and just look forward to any questions or interaction. I do have backups that you can reference later as far as data access, our VLab page. If you want to join the NUCAPS user group, contacting Chris White or Chauncey Schultz. And then some things about visualizations and helpful links and helpful people. So I'll go ahead and leave it there.
Okay, thank you so much, Emily. That was a great presentation. So we will now move on to our discussion. And as Jordan mentioned earlier, that will be facilitated this week by Dr. Stefan Beda, the Science and Operations Officer at the WFO in Amarillo, Texas. But before we do, I just wanted a quick reminder, if you have any questions or comments, please feel free to drop those in the chat room, and we will field those through there. Or if you'd like to ask a question verbally, you can indicate that as well, and we'll make sure that you are unmuted. So without further ado, I will welcome Stefan.
Thank you, and thank you, Emily, for your presentation. We've already had a few questions come in, so I'll go ahead and start off with the first one. Regions are currently assessing data demands as data throughputs are getting saturated at the local weather forecasting offices. What's the data demands that the NUCAPS soundings place on AWIPS, and are all the fields required for the gridded data?
Yeah, that's a good question. So, the data that we're utilizing, the data that's already coming over the SBN. So NOAA 20 soundings come in over the SBN, and we developed an EDEX plugin. And so the gridding takes place with Python within that EDEX plugin. And so that was tested. So as the plugin was developed, it went through testing through the AWIPS program to make sure that there wasn't any adverse effects on data demand or processing within the AWIPS system. And so, as the data comes in, we're basically just creating grids of temperature, moisture, temperature, relative humidity, ozone, and a TPW and a couple LPW layers. And then from there, AWIPS does with it whatever it wants to do, as far as if there's a derived parameter that requires temperature and relative humidity, it'll automatically calculate that field. So I guess, maybe it calculates it when somebody displays something, or I'm not sure if it calculates it right away. That's a little bit far down within the guts of AWIPS. So I don't know of any way to like turn things off, but the same thing happens when model data comes in, that you have a variety of fields that get calculated based off of derived parameters.
All right, well, thank you for answering that question. Our next question is, are there plans for creating a gridded NUCAPS type of product for ATMS? The National Hurricane Center put in the JPSS request for proposal for that and got no bites from anyone. We need the cross-section capability for tropical cyclone analysis. Any answers to that question?
So as far as an ATMS only type of product, we haven't necessarily sought after doing that. With the gridded NUCAPS, you can actually do cross sections by using the volume browser. So that would be an option. So, there would be a lot of value to provide microwave only type of soundings, possibly to Weather Service, to the hurricane community, but right now there's no infrastructure within NWS or within AWIPS to provide the microwave only soundings as kind of a standalone type of product.
All right, thank you for that. So our next question is how can users provide feedback to you and your group as development or updates continue?
You can email myself directly. You can email myself, you can email Rebecca, you could email CrIS White. I think maybe CrIS was talking about actually putting some type of feedback form on our VLab page. So on the gridded NUCAPS page, we'll have to catch up with him on that, on whether or not it was implemented, but we might have a feedback form implemented there.
All right, awesome, thank you. Looks like we have a couple of questions asking about the copy of this presentation, and on behalf of the group, the Tower S team will send out a link with this recording, which will also contain copies of the links that are present within the presentation. So be on the lookout for that in your email boxes when we are done with this presentation. I think that's pretty much all the questions that I see from chat so far. One other question I personally had for you was, what are some of the greatest successes you've heard or seen with the gridded NUCAPS data?
Cold Air Aloft was a lot of fun, and that was one of our first applications that we're really focused on, and I feel like that was a really success. We got to the point where Gail gave us a lot of feedback. She gave us a lot of feedback real time as she was doing dedicated assessments. She would send us emails, how she would see something really excited about NUCAPS. And she wrote a paper too. She led the writing of a paper, and we collaborated with her on it. They started to get to the point where they would have confidence in using NUCAPS as part of their process when they looked for Cold Air Aloft and integrating with the model data and also the radiosondes.
All right, well, that was the last question. Thank you very much, Emily, for answering the questions from the group. I will toss it back now.
Okay, thank you so much, Stefan. Appreciate everybody's time today. And as you see on the screen there, there's opportunity to get in touch with Emily if you have further questions or things come up. Hope you're going to be joining us next week. Again, at the same time, 12 noon Eastern time. Dave Pogazala, he's the Calvel tool manager with the GOES-R ground segment. He's going to be talking about different types of image artifacts and anomalies that can be seen in the ABI imagery, and explain a little bit about why they occur and how we've tried to address them. So look forward or look for an email from the Tower S team on that. So with that, I hope everybody's staying well, having a good rest of your summer, and look forward to you joining us next week. Take care. Thank you, Emily. thank you, Stefan, for being with us today.
Thank you.
Bye now.